Hello everyone, this is a short video on how to query an ontology. More specifically, we'll be focusing on the creation of query graphs for the LACRIMALit ontology. We will start with a short introduction, proceed with examples, and try finally to draw some conclusions. Initially, we want to retrieve data from an ontology, and we can do that by building query graphs and matching them to the ontology. Their creation, therefore, requires the use of Sparkle, a language that allows queries to be addressed to data stored or viewed in RDF format. By specifying nodes and links with variables and standardized vocabularies, along with the utilization of the forms of results of the keywords and the filters that Sparkle defines, results may be filtered and the needed data may be retrieved. The LACRIMALit ontology queried is a deliverable of an IMSS 4th institution project that was built in Protégé using the web ontology language, and its latest version is the second. Now let's move on to the implementation. The first question focuses on the title of the ontology in modern Greek and its subject in English. This user-friendly graph exploits the ontology itself, which is connected to two other nodes. The first node concerns the ontology subject in English by linking them with a has-subject relation, and the second one with a node concerning the title of the ontology in Greek by linking them with a has-title relation. Thus, we can replace the nodes with the URI of the ontology and with variables, and the relations with two standardized properties. More specifically, Dublin Core Metadata Initiative properties are used, referring to the title and the object of a resource. Therefore, the corresponding prefixes are inserted. As we are interested also to retrieve data concerning variables, we use the select form of results, and because we need them in specific languages, we use the filter of language with ISO 639-1 language tags. Finally, here are the results in XML format via the Sparkle General Purpose Processor. The second query graph focuses on the researchers who worked on the creation of the ontology and the role each of them had. More specifically, we create a triple for the ontology itself, then we link the subject of this triple to another node concerning the researchers with the relation has creator for the creators and has contributors for the contributors. Thus, depending on the relationship between the ontology node and the researcher's node, we change the value of each researcher's role. That is why we use the union and the bind keywords along with the Dublin Core Metadata Initiative properties concerning the creator and the contributor of a resource. More specifically, the bind keyword enables us to attach a value to a variable. For example, we attach the value creator to the variable role, while the union keyword enables us to combine pattern alternatives. Thus, here are the results in XML format via the Sparkle General Purpose Processor. The next graph asks the system if the formation Socrates is correct in English. So we ask if there is something in the ontology that has the label Socrates in English. That is why we use the RDF schema property RDFS label, which provides a human-readable version of a resource's name. Lastly, as we are looking for a yes or no question, we use the ask form of results, which matches the query graph to the ontology and returns a Boolean result. And here is the result in XML. In the last graph, we are interested in the hypernym and the hyponyms of the term political action. In essence, we are interested in a node that refers to something that exists in the ontology and is connected to the political action node by the is below relation. So on the one hand, we have the political action as an initiating node, subject, which is linked to something for its hypernym. And on the other hand, we have the political action itself as an object and something else as a subject to retrieve the hyponyms. So in this graph, we use the LAC political action class, which was defined by the creators of the ontology, along with the new RDFS property. More specifically, we use the RDFS subclass of property, which means that its subject is a subclass of a class. Here are the results in XML format. In conclusion, Sparkle can be really helpful for studying, searching and researching resources on web, as accurate answers are returned to accurately built questions. This is exactly where the difficulty of Sparkle lies, as it requires precise syntax and wording with the parallel use of standardized vocabularies, as building the graphs differently may affect the return of results. This is why it is recommended to build the query graphs carefully, as well as to create many drafts and user-friendly visualizations firstly. Here is my bibliography, and thank you so much for watching.